thing that looks like x squared plus bx plus c equals 0. When I look at that, if I called this a u, or I substituted in u, I would have 2u squared plus, and if this was also a u, 3u minus 2. Now this is a lot easier to solve than having this x plus 2 in. So what we're going to do is we're actually going to let u equal x plus 2. Now you have to write this out on an exam or your homework. Otherwise the instructor is going to be like, well, what are you substituting in? It's really important to have that there. So now let's just solve it. So we have 2u squared plus 3u minus 2 equals 0. I'm going to have to do the grouping method here, so because I have a number out here. So 2 times negative 2 is negative 4. And I know that 4 times negative 1 will add to 3. So I'll have 2u squared plus 4u minus u minus 2 equals 0. Since I'm doing the grouping method, I'm going to look at my first 2 and, well, I could pull out a 2u. So I'll have u plus 2. Since I have a negative here, I know I'm going to take out a negative something. Since there's nothing really in common, the only thing in common is negative 1. So once again, I'll have u plus 2 equals 0. And that's good because remember, these two have to match. So when we factor it, we're going to take out the u plus 2, and then we'll have 2u minus 1 left over. Now some instructors want you to substitute back in here, but I'm going to solve it and then substitute. So here we're going to have u equals negative 2, and we're going to have u equals 1/2. I'm going to draw an arrow here up. So we know that u is x plus 2. So instead of writing u, I'm going to write x plus 2. So we have x plus 2 equals negative 2. And then for this guy, we'll have x plus 2 equals 1/2. And now it's just a case of solving for x. So when I subtract 2 from both sides, because I want to get x by itself, I get x equals 0. And then I'm going to subtract 2 on both sides. If you want to do this by hand, we need a common denominator. So that would be 2, so we will have 1/2 minus 4 over 2. So it turns out x is going to be negative 3/2. This should be a 0. And it actually turns out great. So these are our two solutions. Once again, remember we want x squared plus bx plus c equals 0. I have to remember some of my exponential, my exponent rules. This is the same thing as x to the 1/3 squared. Because remember, when you have a power to a power, you're multiplying. So x to the 1/3 squared is the same thing as x to the 2/3 plus 3 times x to the 1/3 plus 2 equals 0. Now hopefully you see what we're going to use substitute. We're going to substitute u in for x to the 1/3. So we're going to let u equal x to the 1/3. So now we have u squared plus 3u plus 2 equals 0. And now it's just a matter of solving it. Well, we know that u plus 2 times u plus 1 equals 0. So u equals negative 2 and u equals negative 1. Remember up here, u is x to the 3rd. So let me bring it up here so I have a little bit more room. So instead of writing u, I'm going to write x to the 1/3 equals negative 2 and x to the 1/3 equals negative 1. To get rid of a third, we're going to cube both sides. So it turns out x equals negative 8, and we're going to cube both sides here, and x equals negative 1. Let's try this one. So once again, we still want x squared plus bx plus c equals 0. I have x to the 1/2 here, and I have x to the 1st. Well, one thing I know is that x to the 1/2 squared is the same thing as x to the 2 over 2, which is x to the 1st. So what I'm going to do is I'm going to change this to x to the 1/2 squared minus 7 times x to the 1/2. Now I haven't done anything different here. I'm just separating out the x to the 1/2. plus 12 equals 0. So as you can see, I'm going to use substitute x to the 1/2. So we're going to let u equal x to the 1/2. So let's do that. So we have u squared minus 7u plus 12 equals 0. We're going to factor just as usual. So we're going to have u minus 3 times u minus 4 equals 0. U equals 3 and u equals 4. So now I'm going to substitute back. I know that u is x to the 1/2. So I'll have x to the 1/2 equals 3 and x to the 1/2 equals 4. I want to get rid of this 1/2, so I'm going to square it. So it turns out x equals 9, and square this one, and it turns out that x equals 16. Let's continue with the same idea. I notice that I have a base of 9 and a base of 3. I need those to be the same. Well, I know that 3 squared is 9. So I'm going to have 3 to the second to the x plus. Now remember, when we're adding, it's the same thing as multiplying. So this is the same thing as saying 3 to the x times 3 to the second. Because remember, when we multiply, we add the exponents. Minus 10 equals 0. Now I notice that I have 3 to the second. But what happens is that I don't want 3 squared to be my u. I want the x value to be my u. So all I have to do is change this to 3 to the x squared, and the rest of it will stay the same. So now I'm going to let u equal 3 to the x. So we'll have u squared plus u times 3 squared, which is 9, minus 10 equals 0. So we'll have u squared plus 9u minus 10 equals 0. We're going to factor as usual. So we're going to have u plus 10 times u minus 1 equals 0. So u equals negative 10 and u equals 1. So now let's put that back in. Since we know that we let u equal 3 to the x, we're going to have 3 to the x equals negative 10, and we're going to have 3 to the x equals 1. Well, it can't be this because we can't think of an exponent, a real exponent, that will make this a negative number. I know that x has to be 0 because 3 to the 0 is 1. So it turns out our answer is x equals 0. I want you to try this one first. So press pause, solve it, and come back to see the solution. This one's a little more difficult than the ones we've done before, mainly because we have this 3 to the negative x. The first thing that I did was I actually changed 3 to the negative x to 1 over 3 to the x equals 5. I really couldn't think of anything that I could use substitute, so what I actually did was I just multiplied everything by 3 to the x. So this gives me 3 to the x squared minus 14. Now 3 to the x times 1 over 3 to the x is 1 equals 5 times 3 to the x. I want to make it equal to 0, so I'll have 3 to the x squared minus 5 times 3 to the x minus 14 equals 0. And now I think it's really easy to see what we're going to u substitute. So we're going to let u equal 3 to the x. So now we have u squared minus 5u minus 14 equals 0. When I factor it, I get u minus 7 times u plus 2 equals 0. So u equals 7 and u equals negative 2. We know that u is 3 to the x, so I'm going to back substitute. So I'm going to have 3 to the x equals 7 and 3 to the x equals negative 2. Well, we don't have to do this one any farther because we know that that's not going to be a real solution. So the next thing is I'm going to change these so I know that the natural log of 3 to the x equals the natural log of 7. This will pop out front, so I have x times the natural log of 3 equals the natural log of 7. So x equals the natural log of 7 over the natural log of 3, which is approximately 1.77.